Welcome back, everyone. This is Session 2, Managing Your Data, and today we're going to build what I like to call your digital filing cabinet. So let's get right to it.
All right, first things first, a huge thank you to our partners. This entire foundational knowledge in data science and AI program is made possible with the incredible support from the Center for Data Archiving, Management, Analysis, and Advocacy, and the Department of Data Science and Economic Policy, right here at the School of Economics, University of Cape Coast. This is our second session of the 12-part series.
So, in our last session, we got our hands dirty with the absolute basics, right? We were storing single bits of information in variables, and we learned how to group a few things together into lists. It was a fantastic starting point, but let's be honest, the real world is, well, it's a little more organized than that.
I mean, think about it. A single variable, like a price, is useful. But data in real life, it almost never shows up one piece at a time. It comes in tables. You see them everywhere: a market receipt, a school register, an attendance sheet. They all have nice, neat rows and columns. They're structured. And our single variables, well, they just can't handle that kind of organization on their own.
And that brings us to the most important question for today. If the whole world runs on tables, how in the world do we work with them in our Python code? How do we take that powerful structured format and bring it into our analysis?
Well, the answer is an absolutely brilliant tool called a Pandas data frame. Now, I know that might sound a bit technical, but the idea couldn't be simpler. A data frame is just a table in your code. The best way to picture it is exactly like a digital filing cabinet, perfectly organized with rows and columns, all set up so you can pull out any piece of information you need in an instant.
Now, you might be thinking, hey, why not just use a spreadsheet? I can click around in there. And that's a fair question, but here's the crucial difference. When you click around in a spreadsheet, those clicks are invisible. They disappear. It's almost impossible to repeat your steps exactly. But your code in a notebook, every single step is written down. It's visible, it's auditable, and this is the most important part, it is 100% reproducible. Anyone can run your code and get the exact same results. That, my friends, is a total game changer for doing reliable, trustworthy work.
So, to make this all really easy to manage, we're going to follow a simple but super powerful 5-step workflow. We're going to use it for our first analysis today. And honestly, you're going to use some version of this for pretty much every analysis you ever do. It's so simple. Load, inspect, rename, filter, and summarize. Let's walk through it together right now.
Okay, before we can even think about writing code to load our data, we have to actually get the data into our Colab notebook. So step 0 really is to find that little folder icon on the left side of your screen, give it a click, and upload your data file, which is called GhanaMarketPrices.csv.
All right, file's uploaded. Now for step 1, load the data. We start by importing our Pandas library. Think of this as opening our digital filing cabinet toolkit. Then it's just one simple command, pd.read_csv. We tell it the name of our file, and we store the whole thing in a variable we'll call prices. And boom, just like that, our entire table of data is loaded and ready to go.
Okay, the data is in. We're done, right? Not so fast. What did we actually just load? A good data detective never just trusts a file blindly. We have to ask some questions first. You know, what's actually in this thing? How big is it? What are the columns really called, down to the exact spelling? And what type of information are we looking at? This leads us directly to our next crucial step.
And that brings us to step 2, the inspection ritual. Seriously, for every single new data set you ever work with, you should always run these 4 commands. No exceptions. It's a professional habit that will save you so much trouble later on. First up is .head. This just gives you a quick peek at the first 5 rows. It's a sanity check to make sure everything loaded okay and to see what the data actually looks like.
Okay, after that first peek, we use .shape. Now, this doesn't show you any of the data itself. Instead, it tells you the dimensions of your table. Instantly, it spits out 2 numbers. First, the number of rows, and second, the number of columns. This is your first quick sense of the scale of your data set.
Next up, we use .columns. This one is so important. It gives you an exact list of every column name, just how the computer sees them. You're going to need these exact names later, and trust me, a tiny typo or an extra space you didn't see will cause an error. This command helps you avoid all of that. Just copy and paste from here.
And the final command in our inspection ritual is .info. This one is the most detailed of the 4. Think of it as a full technical summary of your data frame. It's where we can often spot problems with our data before they become major headaches.
And the info output tells you so much. Let's break it down. The range index just confirms the total number of rows you have. The non-null count, this is your built-in missing data detector. If that number is less than the total number of rows, you know you've got gaps in that column. And finally, dtype tells you the data type. Is it text, which Pandas calls an object, or is it a number? And hey, look closely. Sometimes a date column will show up as object. That's a huge red flag. It means you can't sort it by time yet. It's a data cleaning job we're going to tackle head-on in Session 3.
Okay, inspection is done. Now let's do a little tidying up. Welcome to Step 3, Rename. See, real-world data often comes with column names that have spaces or capital letters like market name. That's actually pretty awkward to work with in code. So a great professional habit to get into is to rename them to a consistent code-friendly format, all lowercase with underscores instead of spaces. Much better.
We're moving right along to Step 4, Filter. Our data set has prices for lots of different things, right? But what if we only care about tomatoes for our analysis? Well, filtering lets us select just a specific slice of our data. This line of code here is really just asking a simple question. Hey, for my prices table, can you give me only the rows where the commodity column is exactly equal to tomato, and we save that result in a brand new data frame called tomatoes.
Now, a quick but super important detail about selecting data. Pay close attention to the brackets. If you use a single set of brackets to select one column, what you get back is a one-dimensional list of values. Pandas calls this a series. But if you use a double set of brackets, even if it's just for one column, you get back a two-dimensional table, a proper data frame. This difference seems small, but it's really important for some of the more complex things we'll do later.
So our data is loaded, inspected, renamed, and we filtered it down to just what we need. Now finally, we can ask a really clear analytical question. Let's try to answer this. Of the markets in our data, which one has the highest average price for tomatoes?
To answer that question, we need to calculate the average price for each market. And that brings us to our final step, Step 5, Summarize. This is where some real magic happens. We use this powerful method called Group By. We're telling Pandas, first, split up my tomato data into groups, one for each unique market name. Then, for each of those little groups, we're asking it to calculate the mean price and also to give us a count of how many prices were in that group. It's incredibly powerful.
And here's what we get back, a perfect little summary table. We can easily see the mean or average price for each market. But don't ignore that count column. That's just as important. See how Kumasi has a higher average, but it's based on 38 records, while Tamales is based on 45? The count tells us about the strength of our evidence. An average calculated from just 2 prices is a lot less reliable than an average calculated from 40, right?
And finally, we get the visual payoff. We take that little summary table and turn it into a simple bar chart. And immediately, the answer to our question just jumps off the page. The chart makes it totally obvious that Kumasi has the highest average tomato price in this dataset. It's clear, it's direct, and anyone can understand it in a second.
So let's just step back for a second and think about what we've done. That 5-step process we just walked through, it did more than just answer a question about tomatoes. It created a transparent record of our entire analysis. A colleague, your supervisor, or even you 6 months from now can open this notebook and see every single choice you made. They can follow your logic, rerun your code, and verify your results. This is the absolute foundation of doing trustworthy professional data analysis.
So look, you've just learned way more than just a few lines of code. You've built a workflow. You've built a professional habit for turning raw data into a clear, verifiable answer. So the only real question left is, now that you have this new power, what are you going to investigate next?